All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over, trying to get there, the Java Early Objects 5th edition book by Tony Gaddis, and we're in the middle of Chapter 2. We left off starting to talk about the combined assignment operators. And the easiest way to show you these right here is to give you an example. So again, as I've been doing, that's what I'm going to continue to do. All right. So I'm going to say here, x equals 21, y equals 22. Okay. Now, so I'm just going to create a couple ints right here. Now, if I want to, I'm going to put 3 dots here, which means there's some code in there. If I want to say x, let's say the person just got a year older, equals x plus 1. I can do that. It's not a problem. But I want to show you 3 other ways that I can do this. So again, increment x by 1. I can also say x plus equals 1. That will also increment x by 1. And if all I want to do is add 1 or subtract 1, I can either say x plus plus, which again will also increment x by 1, or I can say plus plus x, which again will also increment x by 1. All right, but for now, I'm not that concerned with these because we'll talk about this stuff a little later, but not right now. So let's say that where I've got here int x equals 21, they're not ages. So let's say they're the date something is due. In fact, let's do this. Int due equals 21. All right, for right now, we'll just use that. And what if, okay, they didn't pay in that amount of time, so we want to add 30 to that. We could say due equals due plus 30, or we could say due plus equal 30. Please look at what's on the screen right now because these two things mean exactly the same thing. Exactly. And there are 5 of these. If I want to say minus, I can put a minus here. If I want to say times, I can put a times here. If I want to say divide, I can put a divide here. And finally, if I want to say modulo, remember that's the remainder operator, I can put a modulo here. So the point is, with all of the examples, these 5 examples that you see on the screen, actually 10, I'm showing you 5 different ways to either add 30 to a variable, subtract 30 from a variable, multiply a variable by 30, divide a variable by 30, or divide a variable by 30 and get the remainder. So again, the idea is these are called the combined assignment operators. This is the combined plus equals, the combined minus equals, the combined times equals, the combined divide equals, and the combined modulo equals. All right? So that's what they talk about right here. Okay? All right. I've already mentioned that Java is a strongly typed language, but Java likes to work with apples and apples, not with apples and oranges. So if you try to make Java work with apples and oranges, typically It won't complain, but it'll convert something so that it's apples and apples and not apples and oranges. What does that mean? Well, notice right here, int x, int x, double y equals 2.5, x equal y. That's going to give you an error because you're trying to assign a double to an int. You can't do that. Although if you reversed it, you could do it. You can assign an int to a double, but you can't assign a double to an int. So, excuse me, they show the ranking here. All right. What this means is if I add two numbers and one's a double and one is any of the other things other than a double, the other thing I'm adding that's not a double will be promoted, so to speak, to a double. What does that mean? Let's take a look at an example. So if I've got this, int x equals 17.3, 17, double y equals 14.8, double sum equals x plus y. Well, then what actually happens right there is the system does not want to add an int to a double. So what it does is it temporarily promotes a copy of that int to a double and then adds these two. See what I mean? These are now apples and apples. We're now adding the same kind of variable. And that's what a lot of the rest of this chapter here is about when they talk about promoting something. Here's what they call a widening conversion. You're assigning, in this case, an integer to a double. It's okay because you're assigning a smaller type to a larger type. So as it says, a widening conversion is when the value of a lower rank type is assigned to the value of a higher rank type. You can do that. Totally legit. But you can't go the other way, and that's what we looked at before, and that is referred to as a narrowing conversion. So widening conversions, where you go from a smaller to a larger, or assign a smaller one in rank to a larger one in rank, that's okay. Narrowing, when you assign a larger or higher ranked data type to a lower ranked, that's illegal. And that's the example we saw before. How do you get around stuff like this? Well, notice as it says there, you can use casting. I showed you an example of casting earlier. I don't know if I still have that example on here or not. Yep, there it was. Remember? We were trying to divide one int by another and put the result into a double. Well, by default, when we tried doing that, it was going to throw away the remainder. So if we wanted to keep the remainder, we could cast the first or the second, or cast them both. Okay. So they give some examples. One of the things I like about this book, and I've used Gaddis books for years, is that typically he talks to you about something and then he shows you examples. And that's the best way to learn. So right here he shows 5 different examples of using casts. Notice with mixed integer, when values of byte or short are used in arithmetic expressions, they are temporarily converted to ints. The result of combining a byte short, any kind of mixture will always be an int. The bottom line is you find most people for whole numbers always use int, unless they need really humongous numbers if they're doing the national debt or something. And if they need numbers with decimals, they'll almost always use double. Okay. And they show you some examples. So again, if you make everything an int to begin with, you're much better off. All right, let's talk about a constant. So let's suppose Earlier, I think I'd shown you an example here. Where was that? Was that up near the front? There we go. Int legal age equal 21. That really shouldn't be an integer when you think about it. If the legal age is always going to be 21, so this would be a variable. This is a constant. So you say const int. Now, by tradition, constants are always in uppercase. The difference between this and this is once you assign a value to a constant like this, its value cannot change while the program is running. Its value remains constant, hence the name. So the author says here, many programs have data that does not need to be changed. The advantage of using that is if legal age changes from 21 to 18, I only have to change it when I define it from 21 to 18. Not everywhere I use it, but I have to change it where I define it, then recompile the program. So as it says, constants can help keep your program more organized and easier to maintain. Okay, constants are declared with the keyword final. It says constants need not be initialized when they're declared, but they must be initialized before they're used. Typically, you do it like this. Now, I don't do what the author does here with the underscores, and he'll do this throughout the book. At least he's consistent. I would just have run together Cal sales tax, so if that's the sales tax in California, for example. Again, as I said, and as the author says right here, by convention, constants are all uppercase, and words are separated with the underscore character. All right. Java allows you to use strings, but a string is a class. It's not a data type. All right? So it is a class. Now, if I do this, so let's say that I create a variable and I write this. String first name equals Jeff. Okay? What that's going to do is somewhere in memory. So let's say it's going to start, I'm just making this up. I have no idea where it would be in memory. Let's just say it's going to start at location 1000. Okay? The system is going to put Jeff into memory, but it won't put in JEFF. It'll put the zero and the combinations of zeros and ones that equals JEFF. Now let's suppose that later on in my program, somebody says, oh no, you got to use your real birth name. So I got to say first name equals Jeffrey. All right? What happens is the system does not go to location 1000 and add REY in there because there might be something in those memory locations. Rather, what it does is it changes and it gives me a new memory location. So let's say this is at location 5400. Again, I'm just making those numbers up. Then what happens is we've got this thing in 1000 that holds Jeff that's not being used anymore. And we've got this thing at 5400 named Jeffrey, or with Jeffrey in it, that is being used. This location, what happens is that location is flagged for deletion, for lack of better words. Java has a service that runs in the background that's called the garbage collector. Now, this is my analogy. It's not a perfect one, but it's kind of what happens. All right? Back when I was in my teens, late teens and early 20s, I was a student at the University of Wisconsin-Milwaukee. You probably don't know a thing about the campus, but it literally, there are buildings all over the place. In other words, I had my English class or my journalism class in one building, then I had my math class in another building. They were often a 5 to 10 minute drive away from one another. What I tried to do at least once or twice was I tried to park in a 2-hour spot and stay there longer than 2 hours. Well, if you remember the days, and I know it's not as much like this anymore today, but there used to be where you'd have a meter maid that would come around. And he or she would come around and put a little chalk mark under your tire. Then they'd come back 2 hours later, and if the chalk mark was still there, you hadn't moved the vehicle, so you'd get a ticket. Well, kind of the garbage collection in here works the same way. In other words, this location is flagged by the system that says, hey, we've got this variable here or this location in memory that no one's using, so it flags it. Then when the garbage collector comes around a second time after it's flagged it the first time, it says, oh, that thing is still flagged and nobody's used it since I flagged it, so then it removes it. If you want to call the garbage collector in Java, you can do so by saying system.gc. That doesn't mean the garbage collector is going to be called. That means you put a call into the garbage collector. This garbage collector that cleans up, kind of unused memory, etc. That garbage collector is a process of the operating system. So just because I ask for something to happen doesn't mean it's going to happen. If my garbage comes on Tuesday and I forget about it, I can stand out there Wednesday as long as I want to and scream, hey, garbage man, hey, garbage man. But guess what? The garbage man ain't coming. All right. Hopefully that made a little bit of sense. When you create objects, and a string is the first object that we've seen, all right? Objects, rather than holding variables, they hold memory addresses. Now, I don't want to get into this in a lot of detail because you might find it very confusing. But what they're saying is when you do this, and this isn't what I showed you or even what I mentioned before, but it's what happens. When you say string name equal Joe Mahoney, that rather than in memory, rather than having that hold Joe Mahoney, it holds the address of where Joe Mahoney is. So when you work with an object and you make a change to the object, it's a permanent change because you're working with memory addresses. All right. The address for Rankin Technical College in Wentzville is 755 North Parr Road. Now, if for some reason, let's just say that they decided to move to a different location which was bigger, okay? So let's say that they moved to 1515 North Mexico Road, all right? Well, then the inhabitants at the address at 1515 North Mexico Road would change, and the inhabitants of 755 North Parr Road would change, but the addresses themselves would not change. It's just what is occupied at those addresses would change. And it works the same way here. Now, when you say string, like I showed you before, like string first name equal Jeffrey, you can do this. So I could have said string first name equals new string and then in parentheses Jeff or Jeffrey or whatever. But this is a shorthand. So typically you do it that way. When you work with strings, you can find the length of a string. So in other words, with what I showed you before, if I came here and said int len equals first name dot length, it would give me, well, you should all know, right? It would give me 4. And it's dot length paren. So that would give me 4. J-E-F-F. But if I changed it here and now did this, whoops. So I changed the name from Jeff to Jeffrey. Now it's going to give me 7. All right, and that's exactly what they're showing right here. So string objects are immutable. Technically, they can't be changed. But I showed you what actually happens when you do that. All right, I showed you that with a little bit of a picture. All right. When you work with a Java program, what we're going to get to eventually is something that looks like this. So don't worry if what I'm showing you now looks really kind of weird, because we'll get there, okay? So I'm going to come up here and I'm going to do this. Int x equal 10. Int y equal 20. Int answer. Okay? Now, programming is great fun. Now I'm going to say this. Answer. Now, if I said answer equals x plus y, totally legit, and that would give me 30 for answer. But instead, I'm going to do this. I'm going to say add 2, and I'm going to pass x, and I'm going to pass y. What I'm going to do is I'm going to write another method. Public static int add 2 int num1 int num2. Now this may look like it makes a lot of sense right now, but it's something we're going to go over again and again and again. All right. Now, I've got here int x, int y. In fact, I don't even, well, let's do this twice. All right, first time I do this, I'm going to put these in right here. Okay, so there's x, there's y, and there's answer. All right, so this is what's called a local variable because it's declared inside of a method named main. So there's a local variable named x that I've assigned 10 to. There's a local variable named y that I've assigned nothing to. I'm sorry, 20 to. Here's a local variable called answer that I've assigned nothing to. So I'm assigning it here and I'm initializing it here. I could have, instead, I could have gone and just done this. That would have been totally legit. What happens when I put this in is the system says, oh, add 2. So it looks for a method named add2 that it finds right here. And it says, pass me in a copy of x, which is 10. Pass me in a copy of y, which is 20. So in other words, it sees this, but what it actually does is rather than this, it does this. It makes a copy of what's in x and a copy of what's in y. Okay? So this is right here is what's called a method call. So the system looks for a method named add2 that has 2 variables passed into it and that returns an integer. Well, there's a method named add2. It has 2 variables passed into it and it returns an integer. But if you look, well, this is called x and y, and this is called num1 and num2. What's going on? Well, these are called actual parameters because that's their actual name. These are called formal parameters. When I was in high school, my name's always been Jeffrey, but when I was in high school, on my baseball team, I was known as Scotty. So Jeff, or Jeffrey, really Jeffrey, I guess, would have been my actual parameter. My formal parameter would have been Scotty. And the only reason I'm showing you that is what if I wanted to come in here and do this? Int A equal 55. Int B equal 44. Int C equals answer. I'm sorry. Add 2 A, B. So we're going to say x plus y equal, and then we'll say here, plus answer. In fact, let's call this answer 1, and we'll call this one answer 2. Looks a little better, I think. All right, so I'm going to change this to looks like this. So when I do that, what's going to print out here is x plus y equals 30, a plus b equals 99. But what I'm trying to show you is I'm calling the same routine, add 2, twice. In the first time I'm passing it in these two values. The next time I'm passing it in these two values. But in this routine, regardless, they're always referred to as num1 and num2. You're going to see a lot more of this as we go on. All right. That's a little bit about scope. Comments I've already shown you. Single line comments with a // multi-line comments with a /* ending with a //, and block comments. Some people like to pretty their things up so they look like this or one of these. All right. Any comment that starts with a /** and ends with a / is called a documentation comment or a Java doc comment. What does that mean? Well, let's go and look back over here when we looked over here and we looked at this stuff. These comments that you see, like the one right here, all right, that's what's called a Java doc comment. In fact, let's see if we can find a better example. Java doc comment example. So see how they started it with a /**. All right. The reason that you use Java doc comments is you can take your program and the routines and variables you create and use and make them look like the official ones from Java itself. Again, I'm just going to leave it at that for right now. So here's an example. When you run it, you've got to say Java doc instead of Java, and you end up getting something that looks like this. Again, they look very much like regular comments from the Java API or from the Java application program interface. All right, programming style is the way that you visually arrange your code. The system doesn't care what you do. So in other words, you could write this, and it doesn't look like it, but you could write this thing in here like one line, where you squished everything together. It would make it hard to read, but the compiler doesn't care. However, when you write it like this, it's much easier for you to comprehend it. So you put white space and the like into a program for your benefit. The compiler removes all white space anyway. It doesn't care that you've got white space in there. All right, before we go into this reading keyboard input, I just want to make one more comment about programming style. All right. Some people, when they write curly braces, so for instance, public class hello. All right, some people put the curly brace here and then class stuff here and then end it in their curly brace, which is totally fine. Nothing wrong with that at all. Other people do it like this. In other words, do you put the curly brace on a line by itself? That's how I code. But you should code in whatever style you're comfortable with. I wouldn't code a certain way because I do it. That doesn't make any sense. All right, so what I'm showing you are examples of program style. All right, this chapter ends with talking about keyboard input. If you want to be able to read something in from the keyboard, okay, you have to use what's called the scanner class. The scanner class is part of the Java API. What do I mean? I'm going to keep going back to this. I'm going to go over to the Java API, and I'm going to look in here where I've got string now. I'm going to look for scanner. S-C-A-N-N. S-S-C. There's scanner. All right, and I can come down here. You can see again, there's a lot of stuff. So if I want to find out how to use something and I'm not sure, I go out to the Java API. And again, I've been giving you some URLs. Here's another one. There's the Java API. In order to be able to use that scanner class, you have to bring it into your program or do what's called import it into your program. So what this is saying is, I want to import or bring in the Java package that's called util, and I want to use the scanner class that's part of the util package. You're going to start doing a lot of work with import statements very quickly in this class. All right, so what I'm saying is every time I want to create a new scanner object, so when I want to do my system in, I'm going to call it keyboard. This is a great slide because this slide, much better than I ever could, is explaining what's going on here. So just to reiterate what's in the slide, the scanner keyboard declares a new object that's called keyboard that's of type scanner. All right, so this is creating a new variable of this type. This is telling it, since the type is a class, I have to instantiate or create an object of it. So that's what this is doing. And then this says create the object and assign it to that. So the scanner class allows you to read different types of values in. Strings, bytes, integers, etc. But it does not have a way to read in a single character. All right, all the other data types, all the numeric data types. All right, those 6 data types and strings. So if you want to read in only a single character, you read it in as a string and then tell it to grab just the first character of that string. So in this example right here, and this is a great example, not the are we having fun or are you having fun, but you might say something here like, do you want to continue? Y equals yes, N equal no. So if you did that, it would grab everything that you took, but it would only say all I care about is the first character. So Y for yes and N for no, for example. When you work with reading in strings using a scanner, you can run into problems. All right? As it says here, keystrokes, when you key something in, it's kept in an area of memory that's called the keyboard buffer. When you press the enter key, you're telling the system to basically store a new line in the keyboard buffer. All right? And you can occasionally run into problems when you use the keyboard.next line. So it says remove the new line from the keyboard buffer by calling the scanner class's next line method and ignoring the value. The bottom line is this. When you work with some of this stuff, occasionally it works a little funky. So how do you get around that? Well, there's a lot of ways. To me, even when you're working with a console application, so an application that looks like you're using something that is from the a DOS command line, you can use dialog boxes. All right, and these are very similar to using an alert or a prompt that we had in JavaScript. All right, so the dialog box, as it says, it displays a small graphical window with a message to the user. There are 2 basic types of dialog boxes that you use using what's called the JOption pane class. They are the message dialog for output and the input dialog for input. Like we just looked at with this scanner, like we just looked at with this there. You will have to do that import with the scanner because scanner is not part of what you get by default with Java. Well, in the same way, neither is JOptionPane, so you have to import that. Now, you may or may not have noticed, but when we imported the other one, we said java.util.scanner. But when we do this one, we say javax.swing.JOptionPane. Anything that ends with JavaX instead of Java is a newer thing in Java. We'll talk about this in depth in a later class. But the JavaX means that you're working with what are called swing components. So here's an example of an output. There is an example of an input. We will do programs that go through these. All right. This here, right here where it says no, you have to put it in. It's discussed in a later chapter, so you can look in chapter 7 if you want to. All right. But that will end up giving you hello world. It'll say have an I there, which means it's information. That's the title, that's the text, and that's the OK button. So an input dialog is a quick and easy way. So if you want to ask someone their age or their height or their weight, etc., if you put a value in there that's okay and you press it, then it's going to be accepted. If you just press cancel, right there you'll get null. That's what will be in there for the name. So that'll, there's how you build it, and that's what'll happen. So if I type Jeff in here, it'll grab all that stuff and it'll assign it to name. The system is stupid though. If I put 25 in there, it thinks my name is 25. Okay. Now this is a little technical, but what they're saying here is anytime you use these option panes, the system doesn't know that the program is over even when it's over, because these option panes run in what are called a separate process or a separate thread. So you need to put in system.exit like this. Anytime you're going to use those JOption panes at the end of your program, you have to put in system.exit 0. 0 typically, it's traditionally means the program ended gracefully, naturally, successfully, whatever you want, way you want to refer to it. All right. When you use the JOption pane with that show input dialog like this, even if I put in there 25, it's not the number 25, it's the string 25, because anything that you ever put into a dialog box is a string. So if you want to convert it over, so if I want to convert that, if it said what's your age and I want to convert that 25, it's not my age. I wish it was sometimes, but if I wanted to convert that over, then I have to use what's called a parse method. And here are the examples of parse methods on the slide right here. Check my time here. Oh, I'm doing fine. So here's an example. Enter a number. But if I want that number, see, that goes into a string because anything in the dialog box is a string. If I want to convert that to an integer, I use integer.parseInt. It's similar. We used parseInt and parseFloat in the JavaScript class. So the ideas are similar. They're not exactly the same. This integer right here with a capital I is referred to as a wrapper class that we talk about in a later chapter. There's an integer example. There's a double example. All right. The printf, I think I mentioned this earlier. That's something that was kind of gleaned or stolen from the C programming language. It allows you to, the F means formatted output. Okay? So if I use something like this, I work %D hours this week. This %D is a placeholder, and the D does not mean double. The D means decimal integer. So base 10 integer. So that's a placeholder, and that's the actual value. Placeholder, value. Placeholder, value. So that will print, I worked 40 hours this week. Notice if I want a couple of them, so I want to say here we have 2 dogs and 4 cats. %D dogs, %D cats. All right. Here's 3 of them. You get the idea. When you do this, there's other things that you can do here, such as shown right there, you can set field width. So this says have it take up 6 characters, even if I'm only using 1 of them, for example. Here is how you can line things up. Again, is that important? It's not unimportant, but it's not really that important either. If you're working with floating point or doubles, you use %F in both cases. Again, placeholder value. So this will say the number is 1278.92. Now you got those extra zeros there because typically when you print something out with printf to %F, it'll give you 6 decimal places. If you don't want that, you can tell it how many you want. So 0.2F would mean I only want 2 decimal places. And again, these are just examples of examples of the same thing in here. All right, so that's it for Chapter 2. When I come back after a short break, we'll go into Chapter 3. Much shorter. And it's a first look at classes and objects. So I'll be back with that shortly.